Tes, tes.
Hi, Doctor. Hi, Dr. Risman.
Hi.
I'm Idari.
Can you hear my voice?
We
Can you hear my voice? I want to test the voice. Hello? Hello, can you hear my voice?
Very clear, Dr. Risman. Hi,
Okay.
Doctor.
Hi. Hi.
Virus here.
Just want to test the. How to set the background?
Faiz?
Okay, Doctor, you can go to the stop video. At the end of the stop video button, there is a video option. Let me show you. Yeah. I want
In
to
the
share my
setting?
window. Okay, can you see my meeting window?
Yeah, I can see.
Okay, so can you see the video option here?
Yeah.
Okay, you click that and you click change virtual background.
I didn't find change virtual background.
Okay.
So if I click that,
Okay, if you click that, it will appear like this. Okay, like my meeting windows. So you have to go at the plus button here. Okay, you click the plus button and you have to locate where is the video that you put in the download or desktop. The
desktop.
background, yes.
Okay.
Okay. Stop sharing.
I cannot share my screen. Can I test it?
Sorry, Doctor, you cannot share your screen.
Try to share
Okay.
the slide.
Okay.
Let me test.
Okay. All right.
We can see a screen, Doctor.
Okay. If
Okay.
I go to stop video and then there is no change background in my stop video menu.
Okay, Doctor. You are opening WebEx using website. You have to open your WebEx using apps.
Oh, okay.
Okay.
So I have to,
You have to sign off first, and then you have to re-enter.
okay, so I have to log out first and then
Yes.
I will join again with the desktop. Okay.
Okay. Okay. Dia apa ni pasal hot tadi? Dia masuk situ. Dia tanya yang kita download apps ni tu. Yang kita kena masuk.
Knowledge of itself, Samsung Research and Development Indonesia, and followed by our second guest speaker. Yeah.
Coba ya. Assalamualaikum, testing.
Waalaikumsalam, Dr.
Ya,
Zul.
betul.
Ya,
On behalf of the organizing committees, Assalamualaikum warahmatullahi wabarakatuh and good afternoon, ladies and gentlemen. For our webinar today, please be reminded to use the chat pane should you have questions to our speakers regarding their presentations. To enable you to do so, you have to first find the three dots button on your WebEx, then select the Q&A function for you to fill your questions in. Next, the link for you to fill in your attendance will also be made available in the chat pane at the end of the session today. Failure to do so will result to no attendance recorded. For your kind consideration and cooperation in ensuring the smooth flow of our webinar today, thank you very much in advance. Bismillahirrahmanirrahim. Yang berusaha Associate Professor Dr. Haji Zulkifli Muhammad, exercising the function of Rector UiTM Cawangan Kelantan. Yang berusaha Technology Officer Samsung Research and Development Indonesia. Yang berusaha Associate Professor Dr. Anazida Zainal, Head of Information Assurance and Security Research Group, University Technology Malaysia. Yang berusaha Dr. Wan Fairuz Wan Yaakob, Head of Business Analytics Department, UiTM Cawangan Kelantan. Top Management of UiTM Cawangan Kelantan, Heads of Departments of UiTM Cawangan Kelantan, esteemed participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam UiTM di hatiku, salam dari kampus Tanah Serendah Sekebun Bunga, championing entrepreneurship, empowering community. Welcome to the Business Analytic webinar series. On behalf of the organizing committee, I am Idari Ismail, and I would like to extend our warm welcome and heartfelt appreciation to all our participants and dearest ladies and gentlemen to the webinar today. Ladies and gentlemen, Let us take a moment to ourselves to recite the Ummul Kitab Al-Fatiha.
بسم الله الرحمن الرحيم الحمد لله إياك نعبد وإياك نستعين اهدنا الصراط المستقيم
Amin Ya Rabbal Alamin. Dear esteemed participants, this webinar is the first initiative of Business Analytic Department UiTM Chongan Kelantan in collaboration with Business Datalytics Research Interest Group, and we will be conducting more series in the future. With the team making data-driven decisions, deriving evidence from structured and unstructured data, these researchers and practitioners from industries and higher learning institutions in business analytics related field. Ladies and gentlemen, to formally kick our event today, it is my pleasure to invite Yang Berusaha Associate Professor Dr. Haji Zulkifli Mohamad, exercising the function of Rector UiTM Chongan Kelantan, to deliver his welcome address. Please welcome.
بسم الله الرحمن الرحيم
Ladies and gentlemen, sorry, we are having some internet problem, so please bear with us.
Okay.
Ladies and gentlemen, we are really sorry we have encountered some internet connection problem. So due to that, we would like to invite Yang Berusaha as Dr. Sharina Azlin Mat Nasir, Deputy Rector, Research, Industrial Linkage and Alumni of UiTM Chongan Kelantan to deliver her welcome address. Please welcome.
Okay, thank you, Ms. Idari. Okay, welcome all participants of Business Analytics webinar series. First of all, I would like to welcome our two speakers for today. Thank you so much for your time, for delivering your experience, your knowledge to a group of lecturers, researchers from UiTM, University Tanjung Mara, Chongan Kelantan, and UiTM. For your information, this is actually the first webinar series conducted by our new department, Business Analytics Department, with the intention to spearhead in analytics, data analytics platform. On behalf of our rector, we'd like to welcome all the participants to this first webinar series, and I hope this will not be the last, and we will conduct more, try to bring more key players in data analytics so that all participants will not only listen to the speech, but also grab the key elements, especially in this field. With that, I thank you, the organizer of this event, of this webinar. Will get new ideas, new things from our two main speakers for today. So I think that's it from me for today, and thank you. Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you very much, Yang Berusaha, Dr. Sharina Azlin Mat Nasir, for the welcoming speech just now. Ladies and gentlemen, we are indeed very lucky to have our two speakers for our webinar, and today's session will be handled by Yang Berusaha Dr. Wan Marhaini Wan Omar, Head of Faculty of Business and Management, UiTM Chongan Kelantan, as the moderator. Her area of expertise is marketing analytics and supply chain management, halal food studies. As such, I hand over the session to you, Dr. Wan.
Thank you, Madam MC, Ms. Idari. Bismillahirrahmanirrahim. Assalamualaikum and good afternoon. Welcome, everyone. Thank you for joining us for today's Business Analytics webinar series. The theme for today's webinar is Making Data-Driven Decisions, Deriving Evidence from Structured and Unstructured Data. I am Dr. Wan Marhaini Wan Omar, serving you as a moderator for today's webinar. We are very lucky to have these two prominent speakers today, Dr. Risman Adnan Matotorang from Samsung R&D Indonesia, and Associate Professor Dr. Anazida Zainal from University Technology Malaysia, sharing with us on the topics of machine learning for business analytics and business analytics process. Therefore, we are going to have two presentations for today's webinar, and 1 hour will be allocated for each of the presentation. Ladies and gentlemen, just a little housekeeping before we get started. I would like to remind you to keep your microphones off or mute during the session. There will be a question and answer session after each of the session. You can ask the questions directly to the speakers, or you can type them in the chat box. I will bring them up after the presentation. Please take note that if we encounter some trouble in our internet connection, kindly bear with us. I hope everyone will enjoy the session. Ladies and gentlemen, before the presentation begins, allow me to introduce our first speaker, Dr. Risman Adnan Matutoran. Currently, Dr. Risman is a Chief Technology Officer and also a Senior Director Software R&D at Samsung R&D Indonesia since 2014. In his role leading Samsung R&D Indonesia operations, he specialized in attracting and growing cross-functional R&D teams to rapidly build innovative global services, drive business impacts, and build core R&D competency for long-term sustainability. He is an experienced corporate executive, scientist, engineer, and entrepreneur with a diverse background in software product development, technology research, sales, and marketing, and has more than 21 years experience at global technology company as well as startups and also incubators in Indonesia. Before joining Samsung R&D Indonesia, Dr. Risman served as director in Microsoft Indonesia since 2010. Dr. Risman started his tertiary education with a bachelor in theoretical physics and semiconductor from University of Indonesia in 1998. In 2000, he obtained his master's degree in theoretical physics and condensed matter from the same university. Recently, he completed his PhD, specialized in computer science and artificial intelligence from University of Indonesia. Congratulations, Dr. Risman. Furthermore, artificial intelligence is part of his expertise. His expertise lies in optimal transport theory for divergence formulation, energy-based algorithm for minimax optimization problem. He has been involved in many machine learning projects, such as automatic unit test generator for Java language, anomaly detection for mobile system lock, and keyword spotting for Indonesia language. He was also involved in developing open currencies in Indonesia. Without further ado, I would like to welcome our first speaker for today's webinar to deliver his presentation. Dr. Risman, the floor is yours.
Thank you very much, Dr. Wan Marhaini. First of all, I would like to say thank you for the invitation from the UITM Cawangan Kelantan. It's an honor for me to talk to this new audience, and today I will cover a topic about business analytics, but more specifically, I will discuss about how we can apply machine learning for business analytics. In this context, we are talking about business data. So some of the companies that already run for a long time, they produce many data. This data can be transactional data in database from their ERP system or CRM system. We also unstructured data from the application that they created. There is many unstructured data in, for example, the user behavior, like what user click in the website, or what user access in their mobile phone, or photo, or many other data. So the context of this talk is how we can utilize this to make a decision making, and what kind of technology that enable all of the decision making based on data. So the first question we will face, especially if we are working on the company that are producing business data, is how we can understand the data and how we can learn from the data. And based on our learning from the data, we can translate the model into a computer so we can reuse the knowledge that we learn from the data. So learning from data is not a new topic. Especially this have been explored and also in numerical analysis optimization technology for a long time. However, there is some trends that currently being very, very attractive because of the hardware improvement, especially on GPU, so we can train the neural network model faster than before. So there's a lot of model, not only classical machine learning, but also deep learning technology that based on neural network that I also will cover in this talk. So let's back on the first question. Can we learn from data? So assuming that we have data, if we have the label of the data, then we can do many things. However, if we don't have the label of the data, there is only few things we can do. For example, clustering or dimensionality reduction or visualization. But let's talk about data with label. So for example, let's say X is the data. It can be factored. It can be factored from tabular data or factored from image data or any data. And then we have the label Y. And X and Y is actually a pair, so data set and the label. So assuming that we have that problem. So what we can learn from the data is actually we can try to find a known target function f that map X to Y. Of course, the data will have noise. However, we want to have estimation of f. F is unknown, nobody knows, so we can only estimate f. So what the learning algorithm is doing is actually to find hypothesis from the hypothesis set, find hypothesis that can approximate f without knowing f. From the hypothesis set. The hypothesis set can be, for example, linear model, can be a support vector machine, can be any machine learning model like tree or anything. So the learning algorithm, after we define the hypothesis set, will help us to find function g that approximate f with smallest number of error. We call it the error measure must be very, very low. I hope the mathematics is not too hard, but this is the best way to explain the problem. So we have the trained data set X and Y. We want to find function, a known function that map f, a known function f that map X to Y. So this problem, of course, we have faced this problem for a long time. If you remember, Sir Isaac Newton also find gravitation constant using some regression technique from the data that he understands. So in this case, we utilize many fundamental theory from probability, Bayesian statistical method. The good thing here is not like physics where I come from. In machine learning, there is not too many theory. Most of the theory coming from probability, statistic, and physi, maybe physi dimension or bias variance. And actually, most of the algorithm that works in this case is also coming from convex optimization. So the fundamental part is still mathematics. However, there is many machine learning library, many frameworks that we utilize in industry. For example, for linear model, neural network, support vector, we utilize scikit-learn. And for deep learning neural network, we utilize, for example, PyTorch or TensorFlow. So there is many concepts. Also need to acquire the knowledge before we can do modeling, data modeling as a data scientist. So I've been with many people in enterprise that asking me how we can implement machine learning. So the essence of the machine learning is actually first, we need to have data, enough data, not too big data. So many companies say we have peta-sized data or big-sized data, but we don't need the whole data in universe to learn the pattern. The most important thing is inside the data, we have to believe that there is pattern inside the data that we cannot generate some analytical solution for the pattern. If we still have analytical solution, then we don't need machine learning. We need rule-based here. We need just a rule-based technology, like you define how to understand the pattern using rules. But if we cannot find any rules that can explain the pattern inside the data, then we need machine learning. So machine learning is actually the hypothesis set and learning algorithm model that can help us to find unknown function that map the data set to the label. We know this technology as a supervised learning for a long time. So there's many other paradigm in machine learning, not only supervised learning that what I show in this slide. So there is another paradigm called unsupervised learning. In this case, we don't have the label. We just have the data. And currently, the state of the art of unsupervised learning is if we have enough data, we can create synthetic data from that. The model called generative learning. I will explain later. So, analytics first in any company. They have to have data, enough data, not the whole data. Second is, they have to make sure that inside the data, there is a pattern that we cannot explain using rules or analytical solution. If we still find analytical solution, then this is not machine learning. Machine learning problem come from the fact that we cannot find analytical solution. So we just directly learn from the data. And how we learn? So we utilize many techniques, models, and methods. So in machine learning technology, first we try, for example, linear model. In linear model, the hypothesis set that we use to estimate f, the unknown function, is actually linear model. So linear model means the parameter is linearly increased with the function. And we can find many linear model in and we can utilize that, for example, in scikit-learn library. Another model is support vector machine. Support vector machine is a very successful statistical-based learning. This model is being utilized for classification, regression, and many other machine learning tasks to learn from the data. So support vector machine is basically works to find a hyperplan that separate the data that we have. So based on this hyperplan, if we can find the hyperplan that separate the data, we can predict if we have new data, we can predict the class or category of the new data. There's many other models like nearest neighbor, radial basis function, Gaussian process graphical model. But usually if we take I teach AI and machine learning in University of Indonesia. Usually we start with linear model and then nearest neighbor, some radial basis functions, neural network, and deep learning. So how to implement this technology? So it's not about programming at all. So most of people think that data science or machine learning, deep learning technology is like programming tasks. We found out that this is not the case. In programming tasks like building website or web application, the task is very trivial. If we know how to utilize the programming language and the framework, then we can estimate when we can make it done because it's trivial. However, in machine learning project, most of the project is actually discovery process where we don't have the right answer or the right solution. We just estimate G to estimate F. Yeah? We find G to estimate F in this case. This makes us very difficult to find the good accuracy. And to find the good accuracy here, have to have a very strong fundamental knowledge in probability and statistics. It's not about programming. Programming, like in practical area, like utilizing frameworks or utilizing libraries, utilizing GPU, is very trivial. But the fundamental part, when we design the model, when we tune the model, when we fix and improve the model to get better accuracy and generalization, is not programming tasks. It's fully, fundamentally probability and statistics. Even though there is many conceptual, like machine learning models and deep learning models and some technique like regularization and paradigm in machine learning, but the fundamental is not changing. The fundamental still in mathematics, which is statistic and probability. So I really recommend that people who are building the team to build machine learning project, FCP, means that inside the team, they have a people who are actually strong in fundamental, strong in conceptual, and strong in practical, not necessarily at the same person. But in one team, the people who are F will help the team to find out, read the papers, reproduce the code from the papers, utilize the last state-of-the-art model, and the conceptual people will conceptualize this fundamental into a framework, and the practical people will implement. The success of machine learning team is very depend to FCP, means that we need to have core competence on F, C, then P. Not necessary in one person, but this is the minimum configuration. We have 1 people in F, 1 people in C, and 1 people in P. How we implement? First, we collect the data. Some companies say they have the data, but actually the data is everywhere. They cannot collect. So they need technology like data flow technology to make sure that the data can be collected into one place. After the data is collected, we start to curate the data. Curation means we can clean the data, we can pre-process the data, and then make sure that the data is clean enough for further processing. And after that, the data scientists or machine learning engineers will go to the data, usually deployed in data catalog. So many companies now have data catalog. So from the business application, they collect the data, put in data catalog, and then later, the data scientists will try to understand the data, what they have inside the data. The data understanding start usually with the data visualization and exploratory data analysis. So in data visualization, we try to visualize the data. We see the trend of each independent and dependent variables. And then we plot in the chart or dashboard when we try to understand what is this data. And in exploratory analysis, we try to gain deeper understanding by performing more techniques. For example, dimensionality reduction, clustering, etc. Once we understand the data deeply, then we can start to find predictive use case. I see many companies start to go to predictive use case, but they are not understanding the data. They end up with failure. Because first we need to understand our data, and later, then we can have a predictive model. We cannot reverse the process. So predictive model means that based on the data that we have to be able to predict the category. We can predict the future value of the data. So predictive model can be facilitated using machine learning and deep learning. And finally, we can have model, for example, using the reinforcement learning to be more prescriptive. So all of this process should be continuously improved. We cannot make it done in one hit. So all companies who have data scientists, they always improve. They start with the basic model and then they improve. They start with model like recommendation engine, for example, or sales forecast, or for example, fraud detection if they are concerned with the fraud. And after that, they can keep to improve the model, make sure the accuracy is acceptable by the business people, and then they deploy the model and being able to make decision based on the predictive, based on the prediction that provided by the machine learning. So in Indonesia itself, many companies now have the data catalog and data visualization dashboard. They are still in the descriptive analytics. Next, soon or later, once they understand, they can start to move to predictive model. I believe in Malaysia it's the same case, where companies start to be aware of the data. So in the right side, I will explain about technology that we commonly known as deep learning. So basically, deep learning is a neural network with many hidden layers. So the input layer of neural network model is the data. So for example, if we are dealing with the image size 24 multiplied by 24, that's the input layer is actually 24 by 24 factor. And then the output layer is actually the label. So let's, I illustrate the model like this. So each, from the input layer, it will goes to hidden layer. Inside the hidden layer, there is neuron. This neuron perform very simple operation. This is based on our finding in neural science that the human or mammalian brain in general only perform very simple function like step function or spike function in our brain using biological signal. So based on this model, inspired by this model, long time back, we proposed this neural network model as a generic predictor or function approximator for in computer science. So how it works? So it has input layer, it has a hidden layer, and then the output layer is actually the category. So if we have a 5 category to be classified, then we have a 5 output layer. And there is many type of neural network architecture: the deep feed-forward neural network, convolution neural network, the recurrent neural network like LSTM and GRU. And also there is many function of neural network. We can use it as a discriminative model, like how we can differentiate one image to another image, how we understand speech, how we understand text. Another use case is actually generative model, where we generate the data. So we are not only performing the classification and regression, but we generate the data. Maybe I have to give some illustration or demo to make sure that everybody get the idea. So let's say I have this data, and then I want to have computer separate this data. There is two color of the data, so it means that it has two classes. The one is the yellow one and the blue one. And then the data dimension is only 2 dimensions, but I can add more dimension of the data, like the quadrat of the x1, quadrat of x2, I can put as a features inside my model. And then I can add neural network layer. Deeper the layer, bigger the capacity of the network. However, it's also very easy to be overfit if the data dimensionality, for example, if I put too many layers, right? And I can design my neural network, the architecture, like how many neurons I put, or and then I can start to train. All of the neural network models are using optimization technique, usually using stochastic gradient descent. Gradient descent is a very common optimization techniques that we can regularize this using some regularization technique to make sure that it has a good training or stability. To see this model, using this neural network, it will learn how to separate the data. And it will iterate the data using backpropagation algorithm. And it will iterate, and then it will find the space, the white one, that separate the blue data and then the yellow data. We can use more category like this, and I can add more neuron because the pattern that we are trying to separate is bigger, 4 levels. We can try to train it again. Within few minutes. But if the data is big, of course, it takes time because all of the operation inside this neural network is actually matrix operation, matrix multiplied by matrix. So very huge arithmetic computation that we can run easily if we have GPU. Okay, so that is just an example of how we use neural network for classification. And then for computer vision, usually we are using not the plain neural network, but we are using convolution neural network. So what is this convolution neural network? So assuming we have an image data, the image data usually is a data with spatial pattern. So this animation is to show how we can classify the object. So the object is 64 by 64 using RGB because it's a color data set. So huge data set. And then before we classify, the classification will be done by the last layer in convolution neural network. But previous layer, there is a convolution layer. So convolution layer works like a features extractor. So it scan or convolute the image and take the value of the convolution and create another image. So using convolution layer, we can easily extract the features inside the image before it goes to fully connected layer that is implemented as a neural network. Convolution neural network is the state of the art for computer vision that now is no longer in the lab, but we are utilizing this technology in many devices like mobile phone, TV, and every IoT device starting also to put some computer vision intelligence. Using convolution neural net, we can extract image features automatically without having to do manual features extraction. So the other demo that I want to show is generative model. So the previous model that I show is actually discriminative model. You have the data and you want to classify or want to perform regression. In case of generative model, we have the data, we don't have the label because this is unsupervised learning. So let's say we have data that generate this distribution. We assume that we don't know this distribution. This is just a tools to illustrate the idea. So for example, I have the data in this distribution. Can I generate more data with the same distribution? But the data that I generate should not be in the data set. It's a new data, synthetic data, but must have the same distribution with the data set. So the state-of-the-art model for this we call generative adversarial network. So what it does, it has two neural networks. First is a generator network. This generator network will input noise like random Gaussian distribution, and then goes to generator, and then it will produce synthetic data. And then there is another neural network called discriminator. It will differentiate whether the data coming from real data set or from synthetic or generated by the generator. Both of these players, generator and discriminator, is trained using zero-sum game. Means that if the capability of generator increase, the capability of discriminator decrease. If generator can generate more natural data, the discriminator cannot discriminate. If we train this using zero-sum game, we can find Nash equilibrium. And if inside the Nash equilibrium, the generator can generate more realistic data set, and discriminator can no longer differentiate. So just for illustration, this is how the network working. So first, it will generate very far data set. But because we train the model within one zero-sum game, the objective function of generator and discriminator can work together in zero-sum or minimax game to make sure that in equilibrium state or in convergence, generator can generate real data. Not really real, it's a synthetic data. So this technology is already being used by the Face app or Deepfake. So there's many apps now in TikTok, for example, you can see that people can generate video from old picture. They are using this technology to generate image frame from the input image. So this technology is no longer future, but this technology is already here for us to use. How it works? It competes two neural network in zero-sum game using objective, minimax objective. So generator and discriminator minimizing the same objective inside the training. So you can try this later, this to learn the concept. This is a very simplified, but the idea is here. We are using two neural networks, compete them in zero-sum game with well-defined loss like KL divergence loss or Jensen-Shannon divergence loss. And once the loss is decreased and converts, then we can have a model that can generate data with the same distribution with our data set without label. Okay, so I hope you can imagine what is discriminative deep learning using deep neural network and convolutional neural network. Unfortunately, we don't have animation for the long short-term memory and GRU for recurrent neural network. But recurrent neural network is usually being used for sequential data, not spatial data like images. Recurrent neural net is for sequential pattern. And we use commonly used for speech recognition, text recognition, or text understanding and NLU. So back to business analytic case, how we can get this technology being used for business data. Business data is not like speech, it's not like images. Business data usually coming from the business process. It can come from customer data set, like customer profile. If we have a customer profile, we can perform, for example, clustering for customer segmentation. If we have sales data, we can perform some forecasting. We can forecast the data based on the previous year's data set. And we can also use for marketing, like we can do digital marketing and then measure the impact of digital marketing using machine learning. And also in finance, in HR, any company, I believe in the future, will utilize data-driven decision-making. So any students who are learning this technology now, they will have bright future because all companies utilize this technology. There is many examples of the use case, like customer segmentation, dynamic pricing. Instead of we manually set the price of our, for example, online store, we can learn from the customer behavior, their interest on our products, and we can build reinforcement learning engine for dynamic pricing. We can also use machine learning for fraud detection and many other use cases. I cannot mention one by one, but the whole technology being used is described in this deck. First, we should try machine learning, classical machine learning, and then we should try also, after we understand the data using classical machine learning, like we explore the data using exploratory analysis and also visualization, and then we can put in the deep learning model. But the deep learning model, because it uses neural network, usually the parameter is very high number of data compared to classical machine learning. So usually in data scientists, as a data scientist, people have to understand machine learning, classical machine learning, and also deep learning. So if they have a low number of data set, they can still use classical machine learning. If they have a bigger number of data set, then they can try model like deep learning based model. The data set for business analytics, of course, tabular data in database, images, like, for example, handwritten invoice or handwritten check, or maybe in healthcare, handwritten doctor diagnosis. Text and voice. This is a common data set that every company has. However, as I mentioned before, not all companies have a discipline to collect the data, curate the data, and understand the data. So they just have a very raw understanding of their data. So I think to do this, implement this technology for business analytics is to have a very good data collection. That means they need data engineer who take data from ERP, who take data from HR software, who take data from customers, and then put into one data mart. And from this data mart, the data scientists can start to understand, explore the data using statistical and probability techniques. We call it exploratory data analysis. Sometimes they can make dashboard. And after that, they can start to sense what is predictive use case we need to make decision. So it's very hard for any company to jump directly into the predictive model without data understanding. So the task and the phase of implementation should be descriptive, discriminative, and generative model at the last. The technology is there and available. However, we have many risks of the lack of machine learning expert in the market. In Southeast Asia, we are lack of machine learning expert. I think the reason is because this machine learning expert should come from mathematics and statistics background. And then they also have to understand some programming language like Python. But that is the practical part. The fundamental area is still probability and statistics. I have a very long discussion with the Department of Mathematics in University of Indonesia that we need to strengthen the fundamental part in the university. Because some universities try to teach the practical part because they want to align with industry. But from industry point of view, we don't need people who are, we don't need people who know all tools. What we need is people who understand the fundamental, because the fundamental take years to learn and industry cannot teach them. For conceptual, like if they don't understand them in months. For practical tools like developer tools, programming language, we can teach in weeks, but we cannot teach the engineers the fundamental part because it takes years. That's the reason that we need to collaborate with the university to make sure that they back to the fundamental part, not waiting too much on the practical. Because the practical can be easily taught within months and weeks. But the fundamental part is very hard for industry to teach them because we don't have time. The benefit, if we can produce more students who get to know this technology, is the needs of data-driven decision-making and the work productivity is increasing everywhere. Once they have the skill and competence, the trend is in the future is people working everywhere. They can stay in Canada or in US. They can stay in Indonesia. They're working with company in Europe. So I think the trend is very clear after this pandemic, that the remote working and also the working everywhere, as long as they have an industry standard competence. And to build the industry standard competence, I will recommend that the university stay in the fundamental area, strengthen their probability and statistic method understanding, including the optimization. And sometimes we have to reteach the algebra and calculus because that is the base of neural network. And we can take some conceptual in the university, but don't wait too much on practical, because if we see outside, all of the startup company, all of the enterprise company already have the tools. They can learn it from weeks, but they cannot learn back the probability and statistic because it takes years. So that's all from my side. It's clear enough. So if we have questions, then hope we can have time for Q&A. Thank you very much.
All right, thank you, Dr. Rizman. Okay, that was a great presentation. I learned a lot actually, and I hope audience also learned a lot today, where we, get to know a new terminology, a new terms that maybe for some people who are coming from non-technical background, or this could be new terms for them. Okay, because here for the audience here, we basically have audiences coming from different backgrounds, not only from SNT or science and technical background, but also we do have audience from business background. Okay, so what I can say that based on it shows that in business analytics, the essence of machine learning is to have enough data. And we have to make sure that inside the data, there is a pattern.
Yeah.
And machine learning is a discovery concept. However, we need a combination, three combination of people, fundamental people that have a strong fundamental in mathematical and statistical. Okay, and the second one is conceptual people that can develop the framework and the model, and of course the last one would be P, is referring to the practical people. These are the one that are going to implement, okay, what has been planned and developed. So this will help and ensure the success of the analytical project. Okay, so I think we can take maybe one or two questions, and if we have many questions, then we can reserve once all the presentations completed, okay, at the end of the session. But maybe I can take one questions here. This question's coming from Dr. Sharina Azlin. So the question is, to become a business analyst, do graduate need strong domain knowledge of mathematics, statistics, or programming?
So there's two terms actually, the data scientist and business analyst. So business analyst is the one who understands the business process, who understand what data produced by the system they are using in the enterprise. Like for example, they are using ERP or CRM or HR system or many other systems. And business analysts have to decide which data they can collect and what the meaning of the data. Sometimes it sounds like cliche, but assuming that you collect the data and you're asking the people in the company, what the meaning of this column? How we calculate this column? Nobody understands. So for me, is business analyst is the one that we can ask about data understanding after this data is collected. So they must understand the business process and they must understand this data. This data come from this process. The meaning of the data is this. So they have to work together with data scientists or machine learning or AI engineers who are more weighted to the technology. The business analysts have to understand the business and the data and working together with the data scientists who understand the implementation of machine learning model or deep learning model. So these two terms is combined, but there is, we need to be really careful because some people say that we need the business domain knowledge to be able to do machine learning. That is, I think, is not a correct assumption, because when we do machine learning modeling, we cannot be the machine learning. We need to use probability and statistical technique, not our opinion. If we are using our opinion to select features in machine learning modeling step, for example, that's what we call data sniffing. That is prohibited. So we cannot be the machine learning. But we have to use, we have to collect the data, understand the process, and make sure the data is clean for the data scientists. And data scientists have to make decision based on statistic and probability techniques. They have to perform exploratory data analysis, like for example, they have to compare, they have to see the correlation, right? They can use like a correlation technique or measure between one variable to another. They cannot use their domain knowledge for data modeling because that is both of the role is required to deliver a good machine learning model in the company. Business analysts and data scientists.
Okay, all right. Thank you, Dr. Risma, for that. Maybe we can go for the second question. So the second question's from Neep Muhammad Wafi. Okay, in your opinion, which concept is better for real-time data learning? Is it discriminative or the other one? And most of the process nowadays comes from unsupervised technique. Which part should the newcomer should be focused on?
Okay.
Yep.
So we can say data is actually, we can categorize data into batch, means that you already have the data from some time and you take the data. And there is also data that is real-time in nature. Like, for example, you have online commerce, and then you have people who are clicking or viewing the page. The data is coming in real-time basis, right? However, very few machine learning model for real-time data. Most of the machine learning model assuming that you already have the data collected, and then we process in batch, not in real time. There is many other real-time model, like for example, using fast Fourier transform or using a recurrent neural network model that can absorb the data in real time. But I don't think it works. It has a feasible scenario for now, because if the data coming in real-time basis, right, then we have to collect it first before we model it. Okay. However, we can do inference in real time. Once the model is done, right, then we can do real-time inference. Now the industry wants to do the machine learning inference in mobile phone. They don't want data and get the prediction. On-device AI can be done in real time, but the model is already pre-trained. Okay? And also we can also do recurrent neural network model in the local machine that can predict in real time. So not only discriminative model, but we can also perform generative model, reinforcement learning model. Now there is a new trend called federated learning. Federated learning means that when you label or annotate the data, it's labeled on the device. So you don't have to send to server for labeling. You do it in the mobile device, send the labeled data into the server within the permission of the users. So there is many other paradigm is coming for that. And remember that I in my lecture before that I said that we don't need the whole data in universe to make machine learning. So for example, in the election, in the final president can be predicted using 20,000 data. We don't need 1 million or 2 million or 20 million data to predict, because from mathematics we know the patterns of the data is not necessarily the universe of the data. So as long as the data is enough means we assume that the patterns already there inside the data, then machine learning can help. We don't need the whole universe of data to perform machine learning. Okay.
Okay, all right. Thank you, Dr. Risman. So I think we can move on to the next speaker. So maybe at the end, if there is more questions to Dr. Risman, so we can ask you, we can go back to Dr. Risman after end of the second presentation. Okay. All right. Thank you very much for that, Dr. Risman. Okay. Okay. Moving on to our next speaker for today's webinar is Associate Professor Dr. Anazida Zainal. Okay, our lovely speaker, Associate Professor Dr. Anazida Zainal, is an academician and researcher from School of Computing, Faculty of Engineering, University Technology Malaysia. Currently, she is head of Information Assurance and Security Research Group. Associate Professor Dr. Anazida graduated with a bachelor's in computer science from Rutgers University, New Jersey, United States of America in 1990. In 2000, she completed her master's degree in computer science from University Technology Malaysia. She holds a PhD in computer in network security from the same university. Her research work mainly involved in security analytics, cyber threat intelligence, anomaly detection, and artificial intelligence. She has successfully secured many grants, either from university, national, or industry. Some of her research activities has been sponsored by Ministry of Higher Education under Prototype Research Grant Scheme, PRGS, Fundamentals Research Grant Scheme, FRGS, University Transdisciplinary Research Grant, and High Impact Research Grant. She also has secured a research grant from a Ministry of Science and Technology, MOSTI, and a contract research with Cybersecurity Malaysia, Johor Corporations Private Limited, and State Government of. She has been published in several reputable index journals such as ISI, Web of Science, and Scopus, and currently supervising 8 PhD students and 6 masters by research students. In addition, she has been involved in conducting several workshops and training with Custom, Youth and Sports Ministry, and Ikram Johor. Very impressive, Associate Professor Dr. Anazida. Okay, since we only have 1 hour for each of the presentation, so without further ado, I would like to invite Associate Professor Dr. Anazida to present her presentation titled Business Analytics Process. Prof, the floor is yours.
Okay, thank you very much, the MC. Okay, I think some of what has been read, I think it's a bit exaggerated. I'm just a normal lecturer who's coming to the lab every day and going back every day as well. I never stay back at the lab. So it's not that much, it's just, you know, a CV that somebody has to write. Okay, so I'm really sorry. Okay, so anyway, the topic, actually, when I received the invitation, I was thinking what is the best to be presented, because considering that this is business analytics, so I never done any business analytics before, but I'll try my best to match with what I have done to the requirement of today's sharing. Okay, so first of all, let us go and dive into the theme that has been given to us, which is making data-driven decision, deriving evidence from structured and unstructured data. So basically there are, okay, my mouse is not working. All right, okay, so this is the theme that we are going to go through and discuss. And first of all, let me dissect, okay, some of the buzzwords that we have here. For example, the data-driven decisions. This is like a main thing, okay, that we supposed to share, okay, our opinions, what is meant by data-driven. And another part is the structured and unstructured data. Okay, so let us first look at the motivation. Why do we need to do this? Why do we need to do data-driven decision making? Okay, and perhaps I just had a discussion with one of my colleagues, and he was like saying that it shouldn't be data-driven, it should be problem-driven. I think both are correct. Okay, for example, if we want to proceed doing a project or a research, we have to understand the problem first, right? So understanding the problem, okay, will put us in a very good frame, okay, because at the end of the required to solve the problem. So that's why I think both ways are correct. Okay, you can say it is problem driven, but at the same time, it is data driven because you want to get insights from the data. Okay, so the motivation that we have is actually, there are a lot of potential wealth in our data. Okay, perhaps what we are doing is data lake 1.0. We just do data warehousing. We just enrich the data, we discover the data, and we archive the data. But the data can do more than that. For example, we can make money from the data. Okay, some of the applications that we can use the data for example, is predictive maintenance. Okay, predictive maintenance, this is just one of the example. Predictive maintenance means before that particular part, okay, or component of a system go kaput or doesn't work anymore. So you go and you can predict when it is going to fail. So before it's failed, particular component. So that is what we call the prescriptive analytics. Okay, first, we understand the current data, okay, looking at current data and also the past data. We predict when will the failure happen. Okay, so before the failure happen, we already fixed the problem. So here we can see from descriptive analytics, we can go to predictive analytics, and eventually we can go to prescriptive analytics. So we can see that data promise us a very good potential of wealth. Besides that, we can also use for network optimization. I've done quite a lot on this because we want to optimize the network path. Okay, and also when some of my students, we are working on wireless sensor network. Okay, one of the objective is to preserve the resources that we have in terms of power, because we know that node itself, it is battery powered, right? And the battery will, based on the operations that the sensor does, mostly because of the communication, it will warn out the battery. Okay, so what we are doing is we are optimizing the lifespan of the sensor nodes. So a lot of things can be done with the data that we have. Okay, and of course we have sentiment analysis, especially when the election comes. Okay, everyone want to predict whether which particular party going to win the election and so on. So all this can be done by analyzing the data, by predicting and so on. Okay, let me go to the first part, which is data, this is the mainstream, okay, that we are going to discuss today, which is data. There are two types of data, okay, but actually there are three. Okay, but primarily there are only two types of data. One is the structured data, another one is the unstructured data. And the third data type is called semi-structured, or we call it semi-structured, okay? So semi-structured data is sitting in between the two types. Okay, the structured means it has a very clearly defined format. Okay, it is kept in relational database. Okay, but the unstructured data are the data that has various types of format. It can be video, it can be audio, or it can be image, it can be text, and so many things, right? So that is unstructured data. Okay. And then the semi-structured or semi-structured is sitting in between, like I said before. So it is somehow, though it is unstructured, but it has some taggings on it. Okay, for example, like a photo that we have from our smartphone, it has some tags. Okay, like our email, those are the semi-structured data. Okay, and we also know that a lot of researchers, they wrote in article and so on, 80%, more than 80% of the data that we have today, they are unstructured. The unstructured data has some challenges because they don't have a format, and they are, for example, in my experience, I use a lot of textual data, whereby you have to go and first you have to extract the data. Secondly, you have to clean the data, definitely. And third, you have to represent the data. Okay, because the data is in text. So how do you make your machine understand the text? Okay, that's why you have to do word embedding or something that that can represent the text. Or maybe you can do TF-IDF or some other things, right? So that is the challenge when we talk about unstructured data. Okay, so this is an example of structured data. As I said before, the data resides in a fixed field like column and rows, okay, and then it is kept in a record, okay, and the record is kept in the table in the database and so on. And we have like star scheme database, snowflakes database. For those who are doing databases, they should know all the schemes, right? Okay, so the data is very clear and it's very easy to do searching using this particular structured data. They have a data model. So, and the language that is used is SQL or structured query language. And the example of this structured data are Excel, Google Sheets, SQL, customer data, phone records, transaction history, and many, many more. And so far, I think what we have dealt in the past, they are the structured data. Okay, so go to another type of data, which is unstructured just now. Okay, if you look at the box on your left, that is an example of the unstructured data. We have seen that every day. You just open the newspaper, okay, those are the unstructured data. You go and or you go to YouTube, perhaps you want to know what's happening, online news in UK or in China, okay, those are the unstructured data. Every day, okay, when you get bored, you on your Spotify, those are the unstructured data. So unstructured data comes in various formats, okay? So some of the example of unstructured data is text data. It can be social media, comments, postings, phone calls, many, many more, right? And when we look at the quantity, actually there are more than 80% of the data out there, they are unstructured data. Okay, so what we are, most of us, in fact, me, myself, okay, previously, most of the time I was using structured data. Okay, so we only use only 20%. What happened to that 80%? Okay, a lot more that we can get, okay, in terms of insights. Okay, if we can actually go dive into this particular data, clean and get some insights from this data. Okay, all right. So the last one, the one that sits in the middle, okay, which is called the semi-structured data. It looks like this in the box here. We have an example. Okay, so this is semi-structured data format. It is actually, it doesn't have a structure and it doesn't also fit into the formal structure of a relational database. Okay, as I mentioned earlier, in this particular type of data, which is semi-structured data, it employs or
Let's
it
go.
implements. Okay, so it implements tagging system or other markers that separate different elements. Okay, another perhaps another example that is quite explicit is the email. Okay, because you have different sections of the email. That is also considered as semi-structured data. Okay, for example, I've been doing some research in phishing, scam, the website itself. Okay, for example, I've done some research in detection of the fraudulent websites. So the data comes from the text. The data comes from the image on the websites. Okay, so a lot of pre-processing has to be done before the data can be used by a machine learning algorithms. Okay, so let's move on. Okay, now we come to do some comparison between the structured versus the unstructured data. Okay, so the structured data, basically, it can be displayed in rows and columns, but the unstructured data, we just lump that data into one column. So if that article is like 400 or 4,000 lines, okay, it's just one column. So you can have like, you can imagine in your head, okay, how the data is kept. And that's why searching for this unstructured data is quite difficult, right? Because everything is lumped in one column. Unlike its sibling, which is the structured data, we can put the data in the column and row. That's why searching is quite easy to do. Okay. And then in terms of the format of the data, mostly the structured data deals with numbers, dates, and also strings, characters. But for the unstructured data, we have images, audio, video, word processing, emails, spreadsheets, and many more. And according to Gartner, it is estimated that the enterprise data only consists of 20%, whereas another 80% of the enterprise data, they are in the form of unstructured data. Okay, and for the structured data, since it has been structured, it has a very easy, clear format. Okay, it requires less storage. Okay, and then for the unstructured data, it requires more storage. Okay, when we talk about storage here, I think it's worth to mention that when we are dealing with the structured data, most of the time we are dealing with the data warehousing, okay, when we want to do analytics, because the data can come from various sources. Okay, so we dump into the data warehouse. But we cannot do the same thing to the unstructured data. We need another platform, we call it data lake. Okay, later I'm going to show the concept between the data warehouse and also the data lake. And then the last difference between the two types of data is for the structured data, it is easier to manage and protect with the legacy system. Okay, but for the unstructured data, it is more difficult to manage and protect with legacy system. Okay, let us first look at, because I've mentioned about data warehouse and data lakes. Okay, when we do analytics, normally we do not, but it is not always true, but most of the time, we deal with data that comes from various sources. Okay, so the top part denotes the various sources that goes into the data warehouse. So with data warehouse, the incoming data that before it comes and land in our data warehouse, this data has to be clean. If there is a noise, if the data is corrupted, it has to be treated first before it goes to our data warehouse. Okay, so and this data warehouse already we have to define the scheme for that particular database or data warehouse. Okay, unlike on the other side, which is unstructured data, it comes from various sources, but it just get dumped into a lake. You can imagine that you have a lake. Some of the water that comes to the lake comes from perhaps another pond, or it comes from the drain. Okay, so it can be, can you imagine how chaotic or how the data is in the lake? Because if you have like the video is just dumped into that lake. If you have an image, it get dumped to the lake. If you have textual data, it also get dumped to the lake. Okay, so once you have, this is a big difference here. This is a very clearly in the right format, okay, formatted, and this one is still in raw format. So what happened is that if you are the analyst, system analyst or data scientist, if you are working with data lake or unstructured data, it is your job to go and pre-process the data. You can pick up from the lake and pre-process the data. It's actually the job of a data engineer. Okay, so there is like two different posts here. We have data engineer, we have a data science. Data engineer are the people that deals cleaning the data, format the data, and so on. But data scientists will take the clean data and do the modeling, like what Dr. Risman was saying just now. Okay, and then for the people who are dealing with the structured data, life is easier. Okay, because the data is already in format. You just go and do the analytics. Okay, so it's actually, you can see here, the challenge when you deal with unstructured data is a lot. Actually, when you do analytics project with unstructured data, 70% of your effort is actually dealing with the data, getting the data clean. Okay, cleaning the data, formatting the data, extracting the correct information. For example, when you dump everything, it could be from your social media. Perhaps this particular data scientist is working on sentiment analysis, right? We want to know whether is everyone happy with our current prime minister. Okay, so what he needs to do is he will extract data related to that sentiment. Okay, And another person, perhaps he wants to do a basket analysis. Okay, so he go and extract whatever related to the basket analysis project that he wants to do. Okay, that's why it goes back to, you have to first understand the problem, put that in the frame, and decide what are the insights that you want to get from the data. Okay, so then you go and find which data can give you that particular insights. Okay, that's why that's why it goes back to, normally we depend on various sources of data, right? Okay, the next one, I'm going to go to the second part, which is data-driven and data analytics, because I'm dissecting the theme. So we have done on data. I hope we are clear. I know that this is at the very surface level, level 0, because if you go deeper, okay, you have to understand the word to vector, word embedding, and all that. Okay, but I'm not going to go too technical, because this is, to me, this sharing, because the audience come from various backgrounds, I just assume that we just share at the very surface level so that everyone can understand. Okay, because once you understand, then you can start. Part is to get them excited. Okay, what this data can do, what data science is all about. Once the students or the audience get excited, you can go and go deeper and learn about the technical stuff later. Okay, so the second part will be dealing with data-driven and data analytics. Okay, so these two terms are very important as well. Okay, so what is, before I go further, let us look at the data maturity. Okay, because we cannot force one organization to go and implement data analytics, because it is not as easy as that. There are two important things that we have to settle first before we can make sure our organization implement data analytics. One is on data quality, another one is on data governance. Let us go and look at what is meant by data quality. Okay, so there are 6 components of data quality. We say a data is a quality data when it has all these 6 elements. Okay, the data has to be complete or completeness. Okay, that means there is no point if you have the data but the data is truncated or some attributes of the data are missing. We call it missing data. Okay, so you cannot do analytics if your data are not complete. Okay, so the second characteristic of the data quality is that uniqueness. Okay, normally what we do is that before we do modeling, because the first process is make sure that your data are good. Okay, so once your data is good, then we can proceed with the modeling part, what Dr. Risman has covered earlier. Okay, so before we move the data to go to the modeling, we have to make sure that the data are good, the data are the quality data. Okay, so if, for example, if the quality data is not good, but we pass to the modeling part, okay, so whatever the models that produced by name it, whether it is artificial neural network, SVM, deep learning, and so on, of course the model will not be a good model because the input is not a good input, unclean input, or input with a noise. It will affect your prediction if you want to do prediction. It will affect your classification if you want to do classification. Or in fact, it will affect your detection as well. That's why you may have a very high false alarm because of, it could be due to the unclean data or the noisy data that goes to your modeling part. Okay, so completeness is very important. Uniqueness means we want to eliminate the duplicates data, because duplicate data normally when you want to pass to the modeling, it doesn't give you extra knowledge, right? Okay, so we have to make sure that the data is unique. And then in terms of consistency, it deals with the degree to which the data is equal within and consistent. And then it has to be valid. Okay, and valid means it has to be in the right format, right type, and range. Okay, sometimes, okay, it is also important for those who do research or study, okay, to make sure that you get rid of the outliers or you treat the outliers. Outliers are the data that is abnormal. Okay, normally, for example, in a class, in one class, perhaps the height of the student is between 1.5 meters to 1.8 meters. But there is one particular student who are 2.3 meters. So that is called outlier. Okay, so outlier must be treated before we do modeling too, because it will affect your model. This outlier, though it is a data, but it is not common. Okay, so this data has to be treated. Okay, so that is validity, and then degree to which the data represented reality, your data has to be accurate. And finally, the timeliness, it defined as a degree to which the data is available at the time it is needed. Okay, because some decision has to be done in real time. Okay, so timeliness is very important. So that is what is constituted in the data quality. Okay, the next part, okay, because we are still in data maturity, before we go to data maturity, these two concepts has to be ironed out. Okay, so the first one is on data quality. So the second one is on data governance. Okay, again, we cannot say that an organization is matured enough to do analytics if, for example, the data quality are tip-top, all the 6 characteristics are fulfilled, but then in terms of data governance, it is still at a low level. So what is meant by data governance? Okay, so this is the chart that I got from Gartner. Okay, so Gartner defined there are 5 levels starting from level 0. Level 0 in terms of data governance is that there is no ownership of data. Okay, and the data is not secure. Anybody can come and change your data. So the integrity of the data is not ensured. Okay, or the data can be leaked. Okay, so that is dangerous too for an organization. Okay, so that level is level 0. That means there is, the level is called unaware. Okay, there is no ownership at all. Nobody, because a good organization, they should define who is the owner of the data and who are the steward of the data. Okay, the owner of the data and the steward can be 2 different person or 2 different, in our case in UTM, okay, we have 2 different units. Okay, we have the computer center who is the steward of the data, but the data is owned by each of the faculty. Okay, perhaps the postgraduate studies, they own the data, but it is kept by the computer center of UTM. So we have steward and also owner. They are 2 different people in our case, but it is also true that in some cases, the owner is also the people who takes care of the data. Okay, so steward and the owner can be same and can be different people. Level 1 is aware. This is where business and IT leaders start to understand and acknowledge the value of information and enterprise information management. Okay, so we have, of course, level 2, level 3, level 4, and eventually level 5 is whereby the organization has reached its goal in terms of information management. It becomes very effective. Okay, so it goes to, so once we understand this part, now we go to maturity level. Okay, so bear in mind, we have 2 components of maturity just now. We have the quality and also we have the governance. Okay, so how do we say that organization is, that particular organization in terms of their data maturity, it's matured? Or if it is matured, which level it is? Okay, so one article, my slides with the organizer. Okay, so there are 6 types or 6 stages of data maturity. We have lack data for analytics project. This is, though, for example, you have a skilled people, okay, work with your organization, they have all the data scientist skills, but the data itself doesn't have, you don't have enough data, or you don't have the required data to do analytics. You are still considered as lack data for analytics project. Okay, so another stage of the maturity, it is called isolated data projects. This is where each of the team that is in your organization or in business, whereby they are working in silo. Okay, for example, I'm the financial department. I'm just using my data. I'm not sharing my data with other departments. Okay, so that is called isolated data projects. And And the second one is secure, reliable data repository. So this is a better state if you reach this maturity. This is defined as the data warehouse or the lake systems that you have. It has a well-defined management and it is governed well. Okay, that means the governance. There is a governance who's taking care of the data, and the data is also secure. So that means you are at level 2. Okay, and level 3 is whereby it is governed self-service access, where users have access to the expanded data for exploration with data access granted based on the levels of expertise. This is called access level. We give a certain access level to certain people so that we want to keep the integrity of the data, the confidentiality of the data, and so on. In fact, the privacy of the data as well. Okay, so the next one, which is the level 4, is called the Scientific Hub for Data Insights. Okay, here, this is where the organization has the ability to rapidly deploy technology platforms designed to solve specific business problems. Okay, and finally, the last level, this is where we want to be, every organization want to be. Data-driven insights are ingrained or being embedded. It becomes the culture of that organization to use the data before they want to make any decisions. Okay, so that is the highest level. Yeah. Okay, this is only slide 15. I have more. I'm not sure whether I have time. Okay, never mind. I just quickly go. Okay, so now let us move to data analytics. Okay, so what is data analytics? Basically, data analytics, another part. I have another part 2 is data analytics. So data analytics is actually encompass, or it includes the process of cleaning, inspecting, modeling, transforming the data, finding valuable information, informing conclusions, and also enhance the decision-making process. Okay, so basically, when we talk about data analytics, we are talking about how do we get the valuable insights from the available data. Okay, so let us move. Okay, so the process, normally this is, because I want to keep it general, okay. Of course, we have like a very technical process. We try to make it simple. We can divide that into 3 stages. When you want to do data analytics or the basis to any analysis, okay, it can be divided to 3 stages with 6 steps, okay. So the first stage is framing the problem. As I told earlier, okay, before you want to do something, you have to have a problem, okay. You don't go, actually, what are the insights that I can get from the data? That is wrong, okay. We have to know the problem first, okay, and we want to get insights. For example, if I decided to, for example, if I decided, for example, I'm using the basket analysis, okay. We want, actually for the retailers, they want the customer to buy the products. The more the customer buying the products, the better their business is, right? That's why they go into the basket analysis. What basket analysis do is that, okay, every customer, when you go to the counter to pay, okay, assuming that you are bringing 1 basket or 1 trolley, okay, we want to understand, is there any relation between the items that you buy in the basket? Okay, so by knowing, is there any correlation? For example, I normally, when I go and buy things, I will buy fresh milk, I will buy yogurt, okay, those are my favorites, and then I will buy perhaps some cheese, okay. So there is a relation there. So for the retailer, he or she understands my behavior, my purchasing behavior. This is very important. So that, for example, if there is a promotion for these items, they can go targeted market, okay? Or if there is any products that related to dairy product, okay, it's new. Perhaps it's yogurt plus cheese, okay? I'm not sure whether that product exists or not, but if they want to introduce a new product, but that product is actually has similarity to my taste, okay, they know this promotion should be sent to who, okay, and perhaps you guys, I'm not sure, but I do have what we call a membership card, okay, a card, a piece of card that says that I'm the member to this shopping or the retailer. For example, it is Jasco or it is, if it is Giant, okay. So we have a card. So actually, we thought that we want to collect the points. That's why we have a card. But then for the retailer, they want to understand your behavior, okay, because every card has a unique number, a serial number. So they understand the behavior better. What kind of items you bought, okay, and again, as I said earlier, maybe perhaps if they come up with a new products that are similar to my likings, okay, they know who should they send the promotion to, okay. So it is more targeted. Okay, back to this one. Okay, so first of all, we have to know, we have to frame the problem of problem recognition, and then after that, we have to review of the previous findings. Perhaps this particular problems has been, somebody has attempted to solve before. So we have to go back and see so far what has been achieved. We model the problem, okay? Once the problem are modeled, then we have to identify what are the data that required to solve this particular problem. And then we do start with data collection, okay? So once we do data collection, okay, we are ready to analyze the data. And then after analyzing the data, we should be able to get some insights from the data. So based on these insights that we get, okay, now it's time for us to communicate these results to the management. Okay, so basically the job of the data science, this is the job of data science, right? Analyzing the data, modeling the data, getting the insights, and sometimes you have to go to the extent where you have to visualize, okay, the insights, so that the management is easier for the management to see, okay, rather than just numbers, okay, right? Okay, so this is the data analytics maturity model. Okay, so this is again quite important as well. Okay, in doing analytics, normally we begin with a very low level, which is the descriptive. Okay, descriptive means we are just dealing with the present data and also the past data. We want to see the trend, we want to see what is actually happening. And normally when we are at descriptive level, the kind of questions that we ask when we do analytics are what happened, or what is happening, what has happened, that means in the past, and what is happening now, okay? So these are considered as business intelligence, okay? They don't have the capability to forecast or to predict, okay? The next level is called diagnostic, okay? So once you, this is the analytics maturity model. Of course, everyone wants to go to the semantic level, okay? So far what we have done not that much, but maybe 1 or 2 projects that already reach at prescriptive level. Okay. Diagnostic. Okay, this is where we want to identify the factors and causes of the problem. Okay, this is where we do correlation and so on. Okay, and in the diagnostic analytics, the questions that we normally ask is why did it happen? Okay, why did it happen? Okay, so using the techniques such as we want to drill down, the data discovery, data mining, and also correlation, then we should be able to find the correlation between what are the causes to the problem that we see. Okay, so the next level of the maturity is called predictive, whereby we do some forecasting and also the probability as well. Okay, so in predictive, the question that we ask is what will happen? Because so we are now going into another realm, which is to the future. So far, diagnostic, descriptive are present and the past data. But predictive means we are using the past data and the present data to forecast and also to predict what will happen. Okay. Later, I'll show some of the examples that we have done on the dashboard that we did some prediction. Okay. So the next prediction is actually dealing with question, what will happen? Okay, and using the techniques such as regression analysis, forecasting, multivariate statistics, pattern matching, predictive modeling, and many more. Okay, you can do some predictive activities. Okay, the next step is prescriptive. Prescriptive is more to optimize the systems. Okay, like I mentioned before the component fail, okay, we can predict when it's going to fail, and we quickly fix before it fails. Okay, because any component normally it doesn't straight away fail. Okay, it shows some symptoms, but we ignore the symptoms. Just like our health. Okay, we don't feel good, but we keep on working perhaps. Okay, but the symptoms is already there. Okay, so we don't want that component to fail, so we fix before it's failed. Okay, so in prescriptive, basically we can, the question that we ask is, how can we make it happen or not to happen? For example, in terms of failure, we doesn't want that to happen. And finally, the last one is semantics. Okay, I haven't done anything on semantics yet. We're just trying. I mean, still in the stage of doing work on semantic network, but no results yet. So I will not comment on that yet. Okay, right. So the second buzzword or important word in the theme today is the decision making. Okay, so we say that our decision making, when we make decision, it has to be based on the data. Okay, so there are two types of decision making. One is intuition based decision making, and another one is data driven decision making. So what are the characteristics of intuition-based decision making for many years? Okay, so now we start doing data driven decision making. So intuition based making basically relies on gut feeling. You feel like, okay, perhaps this is good to do. Okay, even you want to market one product, you thought that whatever that you like, whatever flavor, for example, you are the ice cream maker, you thought because of you like the flavor, okay, you may think that others will like the flavor too. So you relies on your gut feeling or relies on your own experience. Okay, so another thing is just making the best guess or relies heavily on the past experience that you have, or sometimes it's just quick and non-conscious, meaning that it is difficult to trace the logic behind. It's just something that you feel like, okay, you think this flavor will win your customer, okay, the new flavor of your ice cream perhaps, right? So that is gut feeling, and it is very risky. Okay, so another type of decision making, okay, it is very obvious because we have been talking about data this far, right? So it relies on the facts because there is a data there. Okay, that's why we have to make sure that the data is quality data. Okay, because we want to rely on the facts, and choices are tested, okay, and inspired by previous experience, and the possible means to collect the data is through perhaps the survey responses. We conduct the user testing, we get the response from the users, or we launch a new product to the test market. Okay, so this is how the data are collected. Okay, so what is the benefits of decision making? There are many benefits. Okay, I'm sure you know. Okay, among them, the valuable insights that you get, and then your business continually grow. Okay, improve programs outcomes, and your operations becomes more optimized. You can predict the you gain from the data analytics that you have performed can bring you sort of recommend. I mean, you know what are the actions that needs to be done. That's what we call actionable insights. Insights that prompt you to do certain actions. Okay, for example, like I said before, perhaps the component going to fail, right? Because we predict that it's going to fail in 2 years' time. So it's actually prompt us to do certain actions. That means we have to fix it or we have to service it before it's finally broken. Okay, that part broken or that part failed. Of course, fixing a broken parts is more expensive rather than servicing the parts. Okay, so that is called actionable insights. Okay, so this is the characteristic of the data-driven companies. They understand the data and they know where the data come from and the quality of the data too. A data-driven company and also information and also collaboration. So no longer the departments in the organization work in silo, or perhaps if you have branches, okay, work together with all the branches. You may get certain insights that you by looking at your data alone, okay, you might not get the insights, but by comparing or combining the data with other branches, you get a better insights. Okay, so they keep their data clean, organized, they have the right set of tools and skills, they work with real-time insights, they pay serious attention to data collection, okay, and they regularly update, improve their skills. That's where you send your people or your staff to trainings, and they are able to apply the insights in a way that supports the business goals. So these are the data-driven companies. Okay, finally, the last part is the business analytics. Okay, so what is the business analytics? We have talked about data. All right, it's okay. Okay, so what is business analytics? The analytics is used we use the combination of data, the IT, the statistical analysis, the quantitative methods, mathematical, computer-based model, and many more that we have touched. And also Dr. Risman has touched excellently on this machine learning. And all these can help the managers to gain improved insights. And what it meant is that more evidence, the logic evidence, something that you can explain, okay, about their business operations and make better fact-based decisions. Okay, so some examples of business analytics are human resource planning, the basket analysis, the recommendation system like a Spotify. Perhaps when I talk to my children, she was amazed. How did Spotify know that she likes the music? Because when Spotify recommend the music to her, how does Spotify knows I like this? It's actually what happened is that the Spotify, the engine behind the Spotify is that they do behavior analysis. Okay, you are not the only Spotify user. Okay, there are many Spotify user too. Okay, so based on the existing Spotify user, Spotify is where you listen to music. Okay, and they recommend the music for you or the songs for you. Okay, so what Spotify does or any recommendation system does is that, okay, they look at the larger population and they may do some clustering and they cluster the people, the users or the subscribers, okay, based on the cluster, they understand what is the behavior of that cluster. Okay, for example, you are new to Spotify. When you register, you pick the songs, okay? What the engine does is that by looking at the songs that you pick, they go and look at the existing pattern. The songs that you pick actually match with, okay? So if there is a match, the Spotify or the engine will recommend some of the music that were listened by the people in that particular cluster. That means you are part of that cluster because you have similarity, okay, in terms of behavior. Okay, so that is one example of business analytics application. And in fact, in real life, okay, there are two examples that I found when I Googled last night. Okay, one is in the leadership development Google. Okay, what Google does is that Google is known for the people analytics initiative. Okay, one of the project called Oxygen Project. Okay, so in this Oxygen Project, they try to they mine the data from the 10,000 performance review of their employees. Okay, so they focus on the performers. Okay, people, the staff who perform well. They identify the common behavior of the high performing managers in Google, and then based on that, they created the training program. Okay, so based on this training program they give to their staff, they see a growth in terms of the score of their managers. That means their managers performing better. It's about 5 to 7% better. Okay, so that is the how they use the business analytics or to their operation to improve the performance of the company. So another example is Starbucks. Okay, as we know that back in 2008, hundreds of Starbucks outlets or cafe has been closed. Okay, had been closed, right? So the CEO, which is Howard Schultz, okay, they promised that he is going to use the analytical approach. Okay, so together with one company, which is location analytics company. Okay, this company suggests to them where the actual site or the actual location a cafe or an outlet should be open. Okay, of course, because of the analytics that they did, they make some money, and they open. When they open an outlet, there was a demand there. Instead of you open a certain outlet blindly, okay, but you do some study, you do some analytics. Maybe you study the demographics of that area and so on. Okay, so that is the two real world applications of the business analytics done by Google and also Starbucks. Okay. Yeah, this is just a definition of business analytics. Maybe I can just proceed because I have only 3 minutes left. Okay, I just keep certain parts. Okay, okay. These are the 4 types of questions that can be addressed by business analytics.
Prof, that's okay. You still have more time.
Really? Okay. I need to. Okay.
That's okay.
Right.
That's okay.
All right.
Take your time.
Okay, sure. Okay, thank you. Okay, so there are 4 types of questions that can be addressed by business analytics. Okay, again, it goes back to the analytics maturity as well. So what happened, which is descriptive, it seeks information describing the situation of a product in your, because I try to put into the business perspective. So in this case, we want to know what happened to that product or anything of your concern. In this case, is a product. Okay, we want to know what has happened and what is happening. Okay, or for example, in terms of diagnostic, okay, we aims or the purpose is to understand the reason why that observed event actually took place. Okay, why it happened. Okay, and the third question is when might it happen, is the predictive. The purpose is to understand how to predict when the future event is likely to happen. Okay, if you couple between the predictive and you fix something because of that prediction, you already moved to the prescriptive. That means you want to make it happen or you try to avoid that from happening. Okay, so the prescriptive deals with how I can make it happen, meaning it fixes the problem before it actually happened, like fixing the components that we use in the example that are going to fail. Okay, so but the main challenge in predicting events is often in the creating the mechanism through which people or events might be influenced. Okay, so this is one thing when you want to do prediction that you have to bear in mind. Okay, so basically business analytics that we have talked about, we can conclude that there are 3 types: descriptive, predictive, and also prescriptive. The questions we have covered, and the enablers to this descriptive are the business reporting, the dashboard. Then you can see with the dashboard, right? You can see through the scorecard. Okay, it describes through the scorecard, it describes to you your current status. Okay, through the data warehousing, and the outcomes of this descriptive are well defined, business problems and also the opportunities. This is what we term as business intelligence. Okay, so when you move towards predictive and prescriptive, you are dealing with the future. That's why you need more advanced algorithms or techniques. So you need advanced analytics. Okay, so in predictive, we want to know what will happen, why will it happen. So in terms of enablers, we should be thankful because of the advancement in AI. We have data mining, text mining, web media mining. We have machine learning as covered by Dr. Risman. Okay, and we have the outcomes, which is the accurate projection of future events. Okay, usually from my experience, we don't get 100% accuracy. Okay, but maybe if it is like a complex problem, if you can get 80%, that is good enough. Depends on the domain that you're working with, right? And then For the prescriptive, it answers the problem like, what should I do? Why should I do it? And it deals, the enablers for this is the optimization, the simulation, and also network science. And for the outcomes for the prescriptive is the best possible business decisions and also actions. Okay, so some of the analytics applications that I can share with you, some I have to remove the logo because we did a prototype to certain companies. Okay, all right. So this is the bed management system. This is basically the hospitals. Okay, so this particular company interested to see the occupancy of the bed. Okay, of course, we as a people, we as a human being, okay, we don't want to go to hospital, right? But the hospital wants us to be in the hospital. Okay, the more beds we occupy, the more money it brings to the business. Okay, so it is just that they want to predict and they want to know which particular branch that doesn't make money in terms of bed occupancy. Okay, so in this case, we have a few hospitals here, and this is the ranking, the occupancy rate. Okay, so the managers, by looking at this, they know which particular hospital is highly occupied and which is not. Okay, for example, here, if you look at the bottom left, okay, we have a line here. This is high occupancy, this is low occupancy. So this is the threshold. For example, this is in Damansara, the hospital in Damansara, and also Putri's hospital. They exceed the threshold. That means this particular hospital are performing, and we have to think of the expansion. Okay, and this hospital, whichever that cross the line here on your left side, these are the hospitals which are not performing. But bear in mind, we are using the false data because they don't give us the real data, but they give us the format of the data, and then we impute the data, we create the data, we simulate the data on our own. So this is not actually the actual performance. But here we have, for example, some hospital that crosses this particular line on your left bottom here. So this hospital needs, their management needs to have an explanation, or perhaps they should come up with a better program. Okay, how can they, make their hospital more popular so that people can come and occupy their bed? Okay, so another one, okay, the same, because the dashboard is quite big. Okay, they want to see the monthly trend, the yearly trend, and also the annual admission and monthly admission. Okay, in this case, the blue one is the actual. So we have, we do prediction. Here we do prediction using, so we can see that because the data that we had was until 2017. Okay, so we see that there will be a drop at 2019. Okay, so with this drop, if the management see the drop, okay, definitely you have to think. You know that the bed occupancy will not give you some revenue, some money, right? So you have to think of something. For example, this hospital must think of packaging certain services. For example, the health checking. You want to check your health. Okay, they must come up with some other businesses, but related to health, because they see that there is a declining in bed occupancy. Okay, so before it happen, it's going to happen. So you can focus on other parts of your business that can bring money. Okay, because the bed will not be occupied. Okay, because you cannot go and create a virus and you distribute the virus to make people sick, right? Okay, so basically you can go look for other offerings that the hospital can do, okay, to get more money to the hospital. We have done here, we did a few algorithms, and we found that random forest gives us a better results, and we propose random forest to the customer. We tried with artificial neural network too in this case. All right. Okay. So this is another one, is very low, so it doesn't matter. Perhaps maybe they are more. They are happy if less people come to the hospital. Okay, because they have like huge number of patients that come to the public hospital. But since this is a private hospital, so customer satisfaction is number one to them, right? So here, at the which sector that the government, which sector that the users are not satisfied with their service. So when we look at it, okay, we can see that overall experience is not good, okay, and room facilities and amenities is not good too. But in terms of dietary food, this is the best. I'm sorry, because the outer ring is the score 5, right? So we want to focus to the tip of the which is lower value. So in this case, special attention has to be given to dietary food because many complaints come from dietary food. Okay, here we can also and another one is nurses. Okay, so we can do something. Perhaps we can send our nurses to training, and we can improve on the dietary food. Okay, so this is the overall average mark for all the hospitals. So we take all the hospitals and we take the average. So if, for example, your hospital, whatever that we want to examine or we want to know further, perhaps we take hospital in Sarawak. Okay, so we go into that hospital and we can compare. Are you below the average of the overall average of the hospital for the admission and so on? So here you can see the comparison between your score and the average score of all the hospitals. Okay, and by looking at these two, this is the feedback overview. We can spot these two red lines here or bar here that says that something has to be done in the housekeeping and also dietary food. Okay, in fact, if you click on, you can zoom into which particular comments that they are not, which particular aspect of dietary food that they are not satisfied. Okay, so because most of the time I'm doing the cyber threats, okay, only sometimes I go beyond, I go to another domain, but most of the time I'm doing cyber threat. Among the projects that we did, this is just undergraduate projects, okay? In this case, this particular project, we took the data from Hamagadon website, okay? So these Hamagadon websites provide us quite interesting data. Okay, here we want to see, because the attacker, they have their motive when they attack something. And we want to know what are their motives, who are this attacker, which is this threat actor, and what are the attack characteristic, and we want to know if they attack which platform or which particular domain or the industry that they like to attack. Okay, so it is not surprising because Anonymous is the well-known threat actor that they are very famous because they attack everywhere. And usually when we tabulate, okay, we take the data, we analyze, this is what we get. We found that Anonymous, okay, the actor name Anonymous here, they like to target their attack. When they attack a platform or a domain, they attack using denial of service attack. DDoS means distributed denial. Okay, that means they are targeting, for example, they target Malaysian government platform, right? So the attack may be launched from, this is just an example, from country A, from country B, from country C. So all these countries come from distributed, but the target is one, because the aim is to bring your website down. Okay, so that is the purpose of distributed denial of service. This a lot happen because distributed denial of service is among the easiest attack that we can do. Okay, and mostly they target to government. Okay, government sector. Okay, the second favorite target will be the finance, the law enforcement, the healthcare, the e-commerce, okay, and eventually the telco and so on. Okay, so we can see here that again the famous attack when DDoS, and then targeted attack, the SQL injection, the defacement, web defacement. This is where people go and tarnish your website. Okay, for example, UTM has a website. Suddenly, an attacker go and deface. Now they put instead of UTM logo, they put something else, and they write whatever they write. They can write whatever they want to. Okay, so these are the threat actors. These are the name of the threat actors. They have China, the name China. They have the Dark Overlord, okay, Sony Spooks, and many names, right? And then most of their motive is on the hacktivism. That means they just hack And then this is cybercrime. The second motive is cybercrime, and we have cyber espionage and warfare and so on. And we, again, if we look at this, this is quite interesting, okay? We see that there is none Malaysia, but we heard that we receive attacks. This is because the data that we get from Hamagadon, Indonesia in this case, doesn't have an attacks. We do, but then the data that we obtain from Hamagadon at that time when we do the project, it doesn't have entries for our countries, okay? And then this is quite interesting because why a big dot here happened in Thailand, okay? So when we investigate, we can drill down, we found that this is actually happened because this is one particular employee or staff, they got fired, okay? So this staff retaliate by attacking their companies, his company, his previous companies. So again, it is very important when, for example, when you fire someone or someone retire, okay, you have to make sure that all the accounts closed or whatever that he has an access to certain system, deny the access and so on. So because they can come back and give and attack the system. Okay, so you can drill down by looking at this. Okay, these are description of the event that if you want to see, you can just click and you get the event. Okay. And another one, this is on the online news on hacktivism. Again, this is done by the undergraduate student. What we ask her to do is just get about 300 online articles that deals with hacktivism. Okay, so the five countries that she picked, because these are among the famous countries that reported the attacks: China, Russia, Taiwan, Turkey, and also United States. And then among the attack, we try to analyze in terms of attack types. Okay, attack types, there are botnets and ransomware, distributed denial of service, fraud, phishing, Trojan horse, and these are by the countries. Okay, if you see here for the distributed denial of service, US get a lot of attacks, lot of distributed. And then this is the platform. Okay, they targeted on the government. For example, China mostly targeted are banks and also internet services and also Ministry of Education. For Russia, mostly they target the bank. Okay, Taiwan, they target the internet services. Okay, this is all based on the data. So what we did is actually just a descriptive analytics. Okay, it's enough for the undergraduate student, I guess. Okay, so basically those are the references that I managed to get. And yeah, before I end, if you have any questions, you can ask. Perhaps Dr. Rizwan can also help me answering the questions. No problem. Okay, so with that, thank you. I hope at least it can, we can share something that, that are beneficial to both of our, both of our sides, to both of us. Okay, thank you.
All right. Thank you very much, Associate Professor Dr. Anazida, for your informative talk. Okay. So from your presentation just now, there are a few key takeaways, okay, that I can highlight here. Okay, for summary, the structured data focus will be on the analysis of the data. However, for unstructured data, the challenge will be on the data itself, cleaning, understanding, and etc., which carries 70% of the effort. For both approach, data quality, data governance, and data maturity need to be considered carefully before any analysis can be carried out. Interestingly, by applying business analytics, it can also assist managers, entrepreneurs, business people to make a decision wisely and accurately. Okay, so I think maybe we can go to the questions from the audience. So I think I can see a few questions here. There is this one questions from Mr. Zaihan Osman. Okay, so I think this one actually goes to Dr. Anazida. What are, for example, simple approaches on how to deal with outliers?
Okay. Okay. Depends. If, for example, if you have lots of data, okay. For example, in my case, when I work, my research was on network security. Okay, there are some because my data are the network packet itself. Okay, so when we talk about network packet, we are talking about huge amount of network packets. It's like gigabyte of data. So if I have like 1 or 2 outliers, it's okay for me to just take it out because it will not affect the population of my data, right? So in my case, when the data, to me, if the data is a lot, it's okay for you to ignore the outliers. But if the data is a lot, I mean, you have very small data, that means you have to treat the outliers, okay? It's either, most commonly what people do is that you take whatever the average of the data and then assign that particular value to that particular data. Okay, perhaps it could be due to when you record the data, there is a mistake during the recording. Okay, that's why it's good, like what Dr. Risman said, that you have to do exploratory data analysis first. You want to see your data. If like 1 or 2 outliers very far away from the whole population, it could be because of when you record the data that there happen, some mistakes happen. Okay, so again, back to this question, if you have like huge data, you can just ignore that data. That means you take it out, but for the modeling, because it affects the modeling, right? And then if your data is not that much, you have to treat that, because every data becomes very important to you. Okay, so you have to treat the data. It's either you can put give a value of the maximum, because when you have the data, when you do scatter plot, you know what is the maximum, or you do a box plot, you know what is the minimum and what is the maximum, right? It's either if the data is very large, perhaps you want to assign the maximum value, or you can also assign to the average value to be safe. Okay, but if the data is too small, for example, the smallest data in the population is, for example, integer 5, but you get a data which is 0.00001. So you can see it's very far from the smallest data. Then perhaps you want to assign the smallest range to it. I mean the smallest number, the minimum number.
Thank you. So maybe we can go to the next questions here. What is the difference between fundamental analytics project and applied analytics project? I think this one is referring to maybe the project conducted with the students, or yeah.
Okay. Okay, most of the time, most of the projects that we did to the organization, they are more applied. Okay, that means we don't come up with, we just use whatever the algorithm it is. We use perhaps we can use tools, right? But then when it comes to study that concerning PhD, okay, or masters, you have to have a novelty. Okay, some students, what they do is that they improve the algorithms. Okay, so that, for example, when we talk about optimization, okay, they hybrid certain two optimization algorithms, then they come up with a new algorithm, or they improve a certain part of the algorithm. Perhaps the learning part will be faster, rather than you have to go very lengthy process of training. For example, neural network. Okay, some of the students, if you use neural network, especially the backpropagation, the learning will be very slow, right? So what they did was they used the optimization algorithm to assist the learning in the artificial neural network. So to me, yeah, it is a very distinct research, okay, between the applied. Okay, applied meaning even though you want to work in a applied project, first is you have to understand the problem in the domain, right? In the domain itself, then you just apply to solve the problem in the domain. When we talk about the pure research, we are looking into the tools or the techniques that is used in the data science or data analytics. Okay, what what I see based on my experience, the students are, if it is social science students, they go like applications of data science, but they make a contribution in their domain, which is social science. But for the computer science students, if they do data science, they have to go and do on the techniques itself. So yeah, both consider common, but then applicable to two different groups of people or students.
Okay. All right. So maybe the other thing is that we need to see the level of the students, or like undergrad students and postgrad students. Yeah. Probably it will be different. Yeah.
Exactly. For the undergraduate student, they can do up till predictive, some of them. In fact, one master student, in my case, he's working on the semantic networks. Okay, we are trying to do fraud detection. I cannot reveal too much because I have signed the NDA, so I cannot share that
Sure.
much.
That's
But
okay. Yeah.
basically it deals with detecting the fraudulent activities, and it involves large sum of money in that detection. So we are working on the network graph to do that.
Okay. All right. Dr. Rizman, are you still with us here? I think we have two questions for Dr. Rizman. Yeah.
I'm still here.
Yeah, okay. All right, that's good. Okay, this question goes to you, Dr. Rizman. In fuzzy environment, is it possible to use fuzzy number data in machine learning?
Okay, thank you for the question. So I'm not really understand what is fuzzy means for the data, but I assume that is the data is random. So let me take from that.
Mhm.
So from probability theory, we know that any data is generated by density or probability distribution. The problem is we don't know which distribution or what distribution generating the data. So if we have data that is generated from unknown distribution, now we have many techniques to estimate that unknown distribution. One of the idea is actually generative models that I explained before. So what is generative model? Is density estimation. So if you have a data set, you don't know what is the probability density of generate, but you can estimate this probability density using generative adversarial network. How it works? It creates a neural network for generator. The generator take input on and then generate synthetic data, and the generated data will be compared to the real data using some divergence formulation. You can take the divergence or distance formulation from probabilistic theory or from statistical theory. And then once you get the definition of the distance, you can formulate the loss function. And the model is trained using minimax optimization. So one optimizer is minimizing, the other optimizer is maximizing. Okay, so in case of fuzzy data, so fuzzy is mostly for me is like a method, not the data. So I assume that is the data is actually have some unknown distribution or random. So we don't know. So, but in theory, if you have, for example, of airplane, for example, this 1 million images is actually generated by a probability density that you don't know. However, if you can estimate this density, you can generate new photo of the airplane or that is not in the data set. Okay, so that's my take of the question.
Okay. All right, Dr. Rizman. So hope Dr. Rizman answered your questions, Miss or Mr. Henny Husnia. Okay. The second question, I think this one also goes to Dr. Rizman. as well. It's from Sofianita Mutalib. So, Dr. Isman, can you share some of important practices specifically for sentiment analysis?
Okay. So we do a lot of sentiment analysis. The input data is sentences. You can take from, let's say, from Twitter or from Facebook. People comment in Facebook or Twitter or YouTube comments, and then you crawl it. So the sentence, you cannot put the sentence directly to machine learning library or machine learning model because the sentence is textual, right? Machine learning mostly get the data in numerical format. So what we do, we have to factorize this sentence to make sure that the sentence have some numeric value inside a big structure called, let's say, language model. So language model is an autonomy that all of the language that we use, the words, is structured inside a very big factor or matrix. And if you put those data set into those structure like language model, then you can perform machine learning problem. The sentiment analysis machine learning problem is actually sequential learning. So the sentence contains some words. From these words, you have to categorize this is actually positive sentiment, negative sentiment, or neutral, or maybe you can give more categories like angry or disappointed or whatever. So the problem comes into classification problem. However, the classification problem for sentiment is actually sequential learning because the pattern inside the data is come from the sequence of the words. And the good machine learning model for this is actually recurrent neural network, because recurrent neural network can capture the sequential patterns. So if you have enough data for recurrent neural nets, you can implement LSTM, long short-term memory models, or gated recurrent units, or GRU. But if you don't have enough data, then the problem become quite complicated, because you have to find out which classical machine learning model you want to use. Usually we are using SVM. So SVM, you can imagine the factor inside the data you have is inside is a factor, and then SVM trying to make a hyperplane that separate the data into the class. So if you have less data, try SVM. But if you have enough data for neural nets, you can try LSTM or GRU for sentiment analysis.
Okay. All right. So hope Dr. Risman answer your questions. Madam Sofianita. Okay. We have one more question. So I think this one goes to Dr. Azanida. Can I know the hierarchy of the data process? Yeah, this one goes to Dr. Yeah.
Can whoever that asked the question, can you elaborate? What do you mean by hierarchy of data process?
Yeah, Mr. Fatullah Hadi.
Yeah.
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 You can unmute your mic and then you can ask directly to Dr. Azanida. It will be okay.
Yep. Mm-hmm.
Okay, hi.
Yeah.
I'm Fatul Hadi. I just wanted to know the hierarchy of the data process. I'm just Google about the business analytic, and eventually it what they call the hierarchy of the data engineer and the data scientist, and just mention about the hierarchy of the data process. So is it the same with the business analytic and the data engineer or data scientist?
Okay. I try to comprehend the questions, but if I'm not answering questions, you can just interrupt me. Okay, so basically, when we talk about data engineer and data science, they are two different posts, but it depends. In some organizations, if it is like a small organizations, one person has to do data and engineering and has to do data science as well. But in a quite a medium size of a company, perhaps they can have two different posts. Okay, one is data engineer, another one is data science. Okay, data engineer, basically the scope of work is dealing with the data. That means from the raw data, okay, the extraction of the data, the cleaning of the data. Cleaning of the data, what I mean is cleaning of the data. Some data that we collected have noise, okay, and some data are truncated. Okay, some data has certain values missing. For example, if the data is about yourself, okay, we have your name, we have your name, your age, your occupation, your address, and so on. But one particular field is missing. That is called, we call missing data. Okay, so in terms of missing data, the job of that particular data engineer, he has to treat that missing data, okay, before the data can be used. Okay, yeah, same thing like the questions on outliers. Can we just throw the data? Okay, again, if the data is useful, you cannot throw the data. Okay, so what you need to do is that you have to impute the value for that particular field. Okay, so in order to impute the value, the missing value, okay, this is again still the job of the data engineer. That means cleaning the data, making sure that the data is in the correct format, okay, extracting the data and so on. Okay, so they have to treat the data such that the data is in the correct format, good format. Okay, so that is data engineer. Okay, so data engineer are the people who has to manage the data warehouse, has to manage the data lakes and so on. Okay, and has to interface with the system. Sometimes you need to extract the system from a legacy system. Okay, so you have to write the API so that you can go to that system and extract that particular information. Okay, so that is again the job of a data engineer. Okay, so once the data already in a good place, okay, then the data scientist can come and use the data. For example, if the data needs to be used for the prediction, so the data scientist, whether it is supervised machine learning or unsupervised machine learning or semi-supervised machine learning, in the case that where you have data label, where you have the data but with a small number of labeled data, then you do supervised learning. Okay, so that is the job of data scientist. Okay, so if you ask me what are the skills of data scientist is more like what Dr. Risman has covered. Okay, so the person has to know the modeling, the person has to know all these at least a few techniques, okay, because they have to try on, because not all technique is good for every problem. For example, problem A, maybe only certain techniques is good depending on the domain, depending on the nature of the problem. Okay, am I answering your question?
Yes, Prof. Thank you.
Okay.
From the explanation from the Dr. Anazida just now, so it was clearly differentiate the role of the data scientists and data engineers. Okay, but maybe I can have a few comments from Dr. Rizman in the industry point of view. Okay, so what do you think the difference? Maybe there will be slightly difference between data scientists and business analysts.
Okay.
Yeah.
So data scientists deal with the ready to model data. So usually they are focused on the model itself. If I say model, means that they are focused on hypothesis set and algorithm. And the business analysts focus on understanding the data from the business process. For example, they are using ERP system, making website, and they are making mobile apps. There is structured data in database. There is unstructured data like logs file. So when the data engineer collect the data using some tools, they are using many tools for data collection, usually using open source technology like Airflow or Databits or anything they can utilize. So data engineering focus on collecting the data, make sure the data is centralized into one place. We call it sometimes data mart. And then business analysts will have to understand the data from the business process point of view to make sure that they understand the data, for example, the sales data. The sales data contain the product information, contain the size of sales, contain of distributor or partners who are selling our products. So they have to make sure that the data is there and the data is enough to be processed by the machine learning, by the data scientists. So business analysts working together with data engineer to collect the data, business analysts have to understand the data. The first understanding they should show to the stakeholder is if they can make a dashboard, like operational dashboard, and they can show the trends of the data, they can visualize the data using chart, they can make in a very nice dashboard. So the decision maker can show the trend of the data and can make decision based on the data trend. However, that has a limit. Sometimes if we have a show sales data, business people will say, okay, this will go up. But human have a limited capability. Human is not good statistician. We cannot use human opinion to say the forecast will be like that because they will use their, and every human being have a huge bias. So data scientists have to predict the sales forecast. From the data mart, data scientists will look what kind of features that influence the sales. And then from there, they will collect, they will take the data from data mart that already being collected, and then they will perform machine learning modeling. They can start with classical machine learning, like they can use very simple linear model, or they can use a tree-based model like decision tree, or they can use a more advanced tree-based model like gradient boosting. And if the linear model is not enough and tree model is not enough, then they can find more non-linear model, like for example, neural network. As long as the data is there, the label is there, they can perform supervised learning, they can perform some tasks like classification and regression. So in summary, working with data collection from the sources to the data mart, using many tools, define many standard process, comply to the regulation. There is some data privacy, data regulation defined in European committee. We adopt that, and also in United States now also they have some standard. So we have to comply with that. Inside the data, there is no individual names or example like that. That is data engineering role. And data business analyst role, they have to understand the business process that produce the data. And they have to make sure that each data inside the data mart is well understood. Sometimes they're working on documentation of the data. This data means from this process, this data have some connection with the other data, something like that. And then data scientists will come and then have to understand the business model or business process, because we have business analysts, right? But data scientists should work with probability and statistical method, including machine learning, of course, and also the deep learning techniques. During the modeling, we cannot use our domain or business knowledge anymore. That is bias. We need to work on the data, and the best tools for understanding the data, for explore the data using exploratory analysis is statistic and probabilities techniques. That's why data scientists have a lot of to learn, because at the end, they are the one who have to produce quality model. but they cannot work if data engineer is not there and the business analyst is not there. Okay, that's my answer.
All right, thank you, Dr. Rizman. Crystal clear explanation. So looks like that these two roles is need to be complement to each other.
Yep.
Yep. Yeah. All right. Okay. So I think we have another one questions. This one goes to Dr. Anazida. Is there any guideline for the minimum number of data that is ideal for an analytics project using unstructured data?
Okay. Unfortunately, there is no guideline. Okay. It's just that when I share the one dashboard that I shared from my undergraduate student, because considering they are undergraduate students, so that's why I put a limit. It's not I just that number is just I plug it. I mean, how do I say considering that they're undergraduate student and the difficulty that they have to go and pre-process the textual data, so I put 300. So that is my standard. It's not a guideline or what, okay? But again, it goes back, I think, depending, for example, if you want to know this, sentiment analysis of people about our leaders and so on, what we did, in fact, there was one project that we did in terms of sentiment of the products. Okay, this particular company wants to know how people rate their products, food. Okay, and then as opposed to a competitor. So what we did was we extract the data continuously. For example, in a day around 4 p.m. or twice a day, we extract the data. So the crawler go and get the data, and we make up, based on that, then we give a sentiment score. And then another day, okay, next day, twice, the crawler will go and get the data. So we accumulate the data. So I cannot say what is the best number because depends on the project. If it's undergraduate, to me, 300 is enough because of the difficulties that he has to go through or she has to go through. But then for the real, if you're working for the real, project for a company, okay, this is what we did. It is a continuous process. We just, today perhaps your sentiment score is like this. People love your product more than your competitor, okay, because maybe your competitor then introduce another flavor, and the customer go and they favor the new flavor. Okay, so your sentiment score will change. So it is like a continuous things that we did for that particular sentiment for the products. For the how do I say? Okay, for example, we have Texas Chicken, we have KFC. So what is the sentiment for KFC as compared to Texas Chicken or as compared to McDonald's and so on?
Okay. All right. Thank you, Dr. Rizman. Would you like to give any comments on that question?
It's a very common question from my engineer. How much data we need? So, each model have capacity, and this capacity is actually require amount of data. Unfortunately, there is very less theory on that. There is a good theory from PC dimension. PC dimension is a theory that provides mechanism to measure how many data we need for certain machine learning model. But for very simple model, we can find out the PC dimension formulation, or from this PC dimension theory, we generate the rules of deciding how many data for specific machine learning. But for neural network with a lot of hidden layers, deep hidden layers, and also for machine learning model like SVM or advanced complex nonlinear model, it's very hard to measure the PC dimension. But you can in internet or in papers. For example, you are working with K-nearest network model or linear model. You can find the PC dimension, and you can easily get some estimation of how many data you need to get better accuracy. But again, this is just analysis from theoretical point of view. In fact, it's very hard to measure, to formulate the VC dimension of a complex machine learning model. Only few simple machine learning model you can get the VC dimension.
If you don't mind, Dr. Rizma, VC dimension, how to spell it?
It's the name of a Fafnik and one of a Russian guy. VC dimension. So I will type there.
Yeah, sure. Thank you. Appreciate it.
Yes, so you can find out VC dimension of any specific.
Oh, VC dimension. All right. Okay. Got it.
Patnik and Saber, I forget the
Yeah. All right.
not Korean name, is a Russian name.
Okay. All right. Okay, I think this could be final questions to Dr. Anazida. So looking at your CV, I can see that you had successfully secured many grants from universities and as well as industry. So maybe you can share some tips with academicians here on how to secure the grants, particularly on this field or in this business analytics area.
Okay, just based on my experience, but my list is not that much. I mean, I don't get really good grants. I mean, good amount of grants, but okay, whatever that I have. Okay, so basically what we did was maybe I'm because I'm big research group, okay, and then we have a collaboration with the industry. For example, Cybersecurity Malaysia, because my domain is cybersecurity. So the way cybersecurity works is that they will collaborate with many universities, but each university has to identify what is the domain. For example, in my case, my subdomain is cyber threat intelligence. So any projects that goes that related to cyber threat intelligence, they will collaborate with UTM, for example. But for example, if it is I think forensics. If it is forensics, then they will collaborate with UTM, University Technical Melaka.
Technical.
Okay, yeah. So every university, the way they work is that they have to identify. You have to identify as a university when you approach cybersecurity. You have to identify which particular subdomain under security that you are interested to work with. If that subdomain has not been taken by other universities, then you can, definitely you can work together with them, because I think forensics, I can't remember. Forensic is one of I think maybe UI, I can't remember, but UTM they have collaboration. They have with UIA and as well. So maybe in my case now, I mean, we were lucky because now we are moving towards data analytics. So when we talk about cyber threat intelligence, actually we are, it's just business analytics as well, right? But now the domain is cyber threat. Okay, we use intelligence, we use analytics to solve the problem in cybersecurity. Okay, so that is in terms of collaboration with the Cybersecurity Malaysia. And then and with MDEC, we have we received a grant from MDEC as well, and we set up the Security Operation Lab and also Cyber Range Lab. Okay, this one every 2 years, or is it every year? But we were lucky. In fact, UiTM went. I mean, both of us, tried to get the grant as well. Okay, but maybe I'm not sure how, but we managed to get the grant. Okay, so we are setting up the lab now. So I think as an academician, you have to look out for all these call for proposals. Okay, and then like Mosti, I'm sitting. I'm one of the panel as well. So mostly they open this opportunity all year round. Okay, throughout the year. Okay, so you have to be aware of these openings. Okay, for example, EU, they have Horizon. Okay, you can go to the website and look at the openings. Okay, normally the people in Europe, they're trying to find a partner, okay, in Southeast Asia or in Asia. Okay, so you have to be from time to time, you can go to the website and look for the open calls. Okay, so if the open calls are related to you, you can contact the person who made the open call. Okay, so you can be the team player from the Asia region. They always look for the people from Asian region to work with them. Okay, because that is under EU grants or Horizon. Okay, that is okay. I've covered the government. I've covered the international grant. What else? The university, I'm not sure, but UTM, we do from time to time, every year, we have the encouragement grant or research university grant as well. You can apply. And for the FRGS, FRGS, we have PRGS, and those are from the MOHI or Higher Ministry of Education. Okay, what we did was, even though the call, they have not opened for the call yet, okay, we already prepare, like we have a repository of the proposals, okay? From time to time, we sit in a group, okay, research group, and we brainstorm, okay, what are the things that we can do? If they open for proposal, at least we are ready. We already ready with the proposal. So we have like a repository where when we have idea, we just write it down, we do some literature, and we keep it there until they open for the call. So that is what we did. Yeah, basically this is what we did.
Thank you, Dr. Anazida. Thanks for some sharings, okay, especially to all of us academician. Maybe we can go and explore more the opportunities that we have. Okay, it's just efforts that we need to put and opportunities that we need to grab. Okay, so okay, finally we come to the end part of our session. I would like to thank both speakers, Dr. Risman and also Associate Professor Dr. Anazida, for the insightful and great sharing just now. Thanks also to the active participation from the audience throughout the session. So before I pass the session back to MC, any final words from Dr. Risman?
I thank you for the opportunity to give. I think if you are, for the students who are learning this topic, I will suggest that go to the fundamental area, because in that case, industry cannot help much. We assume that everybody already understands some basic probability theory and statistical methods and numerical methods, including the optimization. And the rest is quite trivial because of the amount of the investment in the industry that we put in the AI and deep learning, machine learning is huge. Then there's lots that we can utilize. Even Google provides free GPU for people who are learning deep learning. So we don't have to invest GPU in the campus. So they can use GPU from Google for 8 hours. So for research, I think it's more than enough for deep learning research. But to get competent in this field, I think takes time. It's not something that we can do in months. I think should be continuous learning. We have to do continuous learning for years. In my team, myself, we built our AI capability since 2015. And we don't think that we can catch up with the rapid progress of the deep learning. So we can only focus on specific use case, but we cannot understand whole. So I think the learning capability and curiosity to learn is also need to be encouraged for students, and because this topic is very. One thing also AI is final. I think we just begin a new journey of utilizing deep learning inspired by the human brain. A lot of model, I think, in the future will come, and it will happen maybe very fast. So we need to start learning today to make sure that we are not lag behind in Southeast Asia, especially country like Malaysia or Indonesia. The level of mathematics and science is quite lower than other countries. So that is my feedback. and comment, Mascom.
Indeed. Thank you, Dr. Rizman, and appreciate your suggestions. Okay, so we at the university should look, into that matter, and we need to go thoroughly and seriously, okay, on that matter if you want to have by the industry, especially on our students. Okay, any final words from Dr. Anazida?
Okay, yeah, because we are both teachers, okay, I just want to share, a little bit. I think as a teacher or as a lecturer, perhaps we need to encourage our students to do this kind of projects as their, either is part of a master's or undergraduate, okay. Of course, a PhD is different. I'm talking about project-based, or in fact, it can be part of the assignment. Okay, encourage them to do more on data analytics, or perhaps what I did was, if the project is big, I will discuss with 2 or 3 of my friends. We break it down and break it to more small projects, and together the 3 of us we supervise the students. And normally we have like 3 of us, we supervise like 7 students. Okay, so this is like a consortium of the supervisors. We learn from the students too, and student learns from us too. So from time to time, because my difficulty is dealing with the undergraduate students. Okay, we have many undergraduate students here, and they don't have enough knowledge to embark on the project like data analytics project. So from time to time, I do like free classes, right, to the students. So if we have like 7 students with this consortium of the lecturers as the supervisors, so all the students, even though they are under my friend's supervision, they can come to my class. So we work efficiently in that sense. Okay, perhaps I just conducted 3 class, my friend conducted 2. That's enough for 1 semester for them to embark, to start, because they don't have in our undergraduate, we do introduce artificial intelligence course, but we don't go further introducing so many techniques in AI perhaps, right? So during these free classes, like I normally do like 1 or 2 hours teach. Okay, for example, today I'm going to teach on particle swarm optimization. So everyone come and they listen what is particle swarm optimization. And then next week, next 2 weeks, perhaps my friend. Okay, so that is more efficient in terms of giving them the basic knowledge so that they can start their projects. Okay, so this is what we did. So we are the one who give them topics. Okay, they pick up the topics, we guide at the very beginning. So after they can, at certain level, they can, take off on their own. Okay, we just need to help them at the very initial stage. But of course, we do encourage them to do whatever domain you are. For example, in my case, mine is cybersecurity, but we still can do analytics. Okay, in your case, for example, if it is business, yeah, we can do business analytics, because analytics is like analyzing the data, and every domain has data, right? So I think it has to be our effort to encourage our student, to get them started. Okay, that's all from me. Okay.
Thank you, Doctor. Appreciate your comments and also your ideas. Okay. All right. I think that will be all from me. So I wish thank you to both of the speakers. Okay. Inshallah, hope to see you again in future. Okay. So thank you, everyone. Stay safe. Assalamualaikum. Over to you, Miss Idari.
Thank you, Dr. Wan. Ladies and gentlemen, we have already completed the forum session today. Thank you to our amazing speakers for their immense sharing today. And thank you to our respected moderator, Dr. Wan, and to all the participants. I hope everyone is doing fine so far, as we have just a bit more to go. Ladies and gentlemen, allow us to have your kindest attention on the screen before we bid farewell. Let's proceed with the final segment for today, the award of certification to our respected guest. First is Dr. Rizman Adnan, Chief Technology Officer of Samsung Research and Development Indonesia. and followed by our second guest speaker, Associate Professor Dr. Anazida Zainal, Head of Information Assurance and Security Research Group, University Technology Malaysia. Once again, thank you very much to our speakers. Ladies and gentlemen, we have come to the end of our program. On behalf of the organizing committees, I would like to express my utmost gratitude to all of you for making our business analytics webinar a huge success. And we would like to apologize for inconvenience caused due to the interruption of the internet connection. All right. Kind consideration to enable your webcams or mobile cameras for us to virtually pose for a photo in commemorating our session today. All right, so we're gonna have few takes. Please turn on camera. Ready, everyone? All right. On the count of 3, 2, 1, smile. All right, another one take. Ready? On the count of 3, 2, 1, smile. All right, thank you, everyone. Please make sure that you have filled in your attendance for today, as that counts for your training hours. The link is available in the chat section. Ceremony with the recitation of Tasbih Kafarah and Surah Al-Ars. Thank you very much and have a pleasant day. Assalamualaikum.
Thank you, everyone.
Thank you, everyone.
Thank you,
Thank
Dr.
you.
Rizman. Thank you, Dr. Anazida.
Thank you.
Thank you, Doctor.
Thank you, Dr. Rizman. Thank you, Dr. Anazida.
Thank you.
Bye.
Bye.
Yeah, please. If I turn off camera.